Hey everyone, I'm Nitya from KL University Hyderabad here with amazing topic today, ALEXNET architecture, an architecture which challenges the CNNs. Let's get into the topic. Years ago, we have used small datasets like Cypher and Knock consisting of thousands of images and a small number of classes. These datasets were sufficient for machine learning models to learn basic recognition tasks. But in real life, these small datasets doesn't work, right? As we had many more variables to be added to these small datasets. So, if there is a dataset like ImageNet which has thousand object classes and more than a million training and testing labeled images, which has pushed the need of an extremely capable deep learning model. Then came ALEXNet. Let us learn about the ALEXNet architecture. ALEXNet architecture consisted of 8 layers in which 5 were the convolution layers and 3 were fully connected layers. In a detailed view, the 5 convolution layer consisted of 3 max pooling layers and 2 normalization layers. Under the fully connected layers, there were 2 fully connected layers and a softmax layer. The activation function used here was ReLU and the learning algorithm was SGD momentum. So in the first convolution layer, there was an input image of size 224 by 224 by 3 which was passed into the convolution layer. It uses 96 kernels of size 11 by 11 by 3 with a stride of 4. In the second convolution layer, it uses 256 kernels of size 5 by 5 by 48. The third, fourth, fifth convolution layers, we had 384 kernels of size 3 by 3 by 256. So this is about the convolution layers. Coming to the fully connected layers, each fully connected layer consisted of 4096 neurons. But how did ALEXNet unique from the other existing architectures? There were 3 factors which made ALEXNet unique from the other architectures. First factor was usage of ReLU activation function which added nonlinearity. The second was the usage of dropout. Dropout is a regularization technique to deal with overfitting and which improves the generalization of deep neural networks. And the third factor was pooling. Pooling is used to reduce the size of the network and it also helps in reducing the overfitting. So this is about the ALEXNet. Now let's get into the coding part of ALEXNet. So we use the libraries TensorFlow and Keras of Python to build this model. We use a sequential model, and as said, we have 5 convolution layers. In the first convolution layer, we had filters. Filters are 96, and the input shape, like input size of the image, is 224, 224, 3. And as said, the kernel size and the strides, we have discussed this, and the padding is valid. Like it has a padding. Model dot add, like this, it adds the ReLU activation function to the first convolution layer. Then we add the max pooling layer and we have batch normalization. In the same way, second layer, we have 256 filters and the kernel size is 11 by 11 and its strides we can mention or it may not be mentioned as the stride value is only 1. If it is 2, 3 or 4, it may be mentioned. So padding is valid again and we use the activation function ReLU here, and again the max pooling and the batch normalization layers are added. In the same way, third convolution layer which has filters 384 and the kernel size is 3 by 3. Even here the strides need not be mentioned, but for our convenience I've mentioned here, and the activation function is ReLU. In the same way we describe convolution layers 4 and 5. Now here we are flattening the model, which means as discussed we have 5 convolution layers and 3 fully connected layers. Let us learn what flattened is. Suppose we have a pooling layer like this. So this gets converted into an input of a neural network. This gets flattened into the input of neural networks and this is sent to the neural network. So this is what happens in flatten. So in the first, we add a dense layer. What is a dense layer? It is nothing but the neurons of the previous layer will be taken as the input to the next layer. And here we have a activation function ReLU, and we add dropout as we have discussed to prevent the overfitting. In the same way, we have second and third dense layer. So didn't you get a doubt why we use softmax layer? Softmax layer, the output which is interpreted from the neural network, it gets directly interpreted to the probability. Like suppose if we have an example, a person has COVID or not. Okay, it's a small example. In that, if we are applying this model to that kind of an example, it only gives two outputs. A person has a COVID, yes or no. So the output of this model will directly interpreted as 0 or 1. 0 means a person has COVID, 1 means a person is not having COVID. So that is why we use softmax layer in the fully connected layers. So this is about ALEXNET. Hope you like this video. Thank you.